Hello, I'm Ryan with High Desert Math Tutor, and today I want to talk to you about the difference between simplifying, evaluating, and solving. Now, many people use these three terms interchangeably, but they are not quite interchangeable. What I mean is, each of these is a verb, and we need certain verbs when there are certain actions we're trying to describe. For example, if you're hungry, you wouldn't say, "Hey, can you go drive my microwave for me?" Drive your microwave. Things of that nature. We want to correct that in this video. So to begin, the most common objective that we see when you're beginning in math is to simplify. But what does it mean when we say simplify? Well, for example, I could say I'm recording this video at 2 times 5 minus 4 o'clock. But that was not simple. I could just say 6 o'clock. So simplifying means take whatever you have, just make it the easiest possible version of itself. So let's see this. So if we say 3 times 2 plus 1, and that whole thing is being squared, we just follow the order of operations, which is PEMDAS. So what we see, we first go inside the parentheses. We see, is there any multiplication or division? There is. So what we have here, 3 times 2 becomes 6. We still have our plus 1, and everything is still being squared. Next, we have 6 plus 1, which is 7. And 7 squared is 49. So instead of saying, yeah, you know what, I'd like 3 times 2 plus 1 to the power 2 apples, you could just say, yeah, when you go to the store, we have a big event, could you just buy 49 apples? So the idea is that we're taking something that looks very complicated and turning it into something very simple. That's what simplifying means. But notice, here, there are only numbers and operations. Most of the time when you say simplify, that means take all these numbers and these operations and turn that into one single number. Next, we have evaluate. So evaluate is what we mean when we say evaluate something. We have a function or an equation that has a variable in it. And what we want to know is if we decide to change this variable to the number 5, for example, what does this turn into if x was to turn into 5? So this means we know some sort of relationship right here. We know a relationship, but we're asking what does that relationship become when we change something? When we plug in a number instead of a variable. That's when you say evaluate. So what we can say is if we want to evaluate f at 5, so when x turns into 5, then what we have, instead of x squared minus 6, we have 5 squared minus 6. So 5 squared is 25, and 25 minus 6 is 19. So when we evaluate f at 5, we evaluate f at 5, that becomes 19. Another way of looking at this, just to be clear, is when x is 5, y is 19. And even though that's not the focus, like function notation isn't the focus of this video, I just want to remind everyone that anytime you see f of x, this is another way of saying y. So f of x is the same as y. So when you evaluate f at 5, the answer is 19. Or when x is 5, y is 19. So to recap, we have only numbers and operations here. And if we want to make this simpler, we simplify into a single number. when we have a relationship or a formula with variables in it, and we want to replace those variables with numbers, we evaluate what this turns into. When x becomes the number 5, we get 19. But now solve. Solve means something very different than simplify or evaluate. Solve means that we have a relationship like 5x minus x plus 3, and we want that to be the same as 2x minus 1 plus 6. So we have two things that we want to be the same, but initially these are not the same. They don't look anything like each other. So what our goal is to figure out what does x have to be so that this turns into the same number as this. That's when you solve, when you know some relationship and you want to make sure everything becomes either the same, or you're trying to find out what numbers you need to replace variables with to make this statement true, the statement that this is the same as this. So here, we'll start by just combining like terms. So what we have here, we have 5x minus x. Well, if you have 5 x's and you just take 1 x away, that means now you have 4 x's. But we still have plus 3. Over here, we only have one term with an x, so we'll bring down the 2 x's. But this right here is like saying you have $6, but you're spending $1. That means you only have $5 now. Next, whenever we have an equation we're trying to solve and there are x's on both sides, I always recommend looking at which side has the fewest number of x's. So see here, this is saying we have 4 x's. This is saying we have 2 x's. Since there are fewer x's here, I'm going to subtract 2 of those x's from the right side of the equation to get rid of those. And I'll subtract 2 x's from this side of the equation, because whatever you do to one side of an equation, you have to do to the other side. So you had 4 x's, you take 2 x's away, that means you still have 2 x's left over. We will bring down the plus 3, and we will bring down what's left over here, which is just 5. Now that we have all the x's on one side of the equation, we're just going to get rid of everything around this by going through the order of operations backwards. I've talked about that in other videos, so I won't go into all the details today, but the first question is there any addition or subtraction happening around x? There's addition, so we'll get adding 3 to go away by doing the opposite, which is subtracting 3. But if we subtract 3 from the left side of the equation, we'll subtract 3 from the right side of the equation. Those cancel. What we have left over is 2x equals 2. Now we ask, what does it mean if a number is touching a variable? Well, the operation between them is multiplication. And the opposite of multiplying x by 2 would be dividing x by 2. But if you divide one side of your equation, you have to divide the other side of your equation. These cancel, and we see if x is equal to 1, then 5x minus x plus 3 is the same as 2x minus 1 plus 6. So when you solve, you're finding a number that if you substitute that number into this equation, it makes this side the same as this side. It makes the statement true. So that is a quick little overview of what the differences are between simplifying numbers into a simpler version of itself, evaluating what a relationship turns into when you substitute a certain number into this formula or relationship, and solving a goal. We have a problem, a goal to make this side become the same as this side. And when you say you want to solve an equation, that means you want to figure out what number should we replace the variables with to make this equation or this statement true, which it looks like in this case, if we make x equal 1, the statement becomes true. Well, that's all I have for you today. But as always, feel free to like, comment, subscribe. If you have any problems that you'd like to suggest, feel free to put them in the comments and I'll make a video in the future.